Section 1.3, the PowerPoint voiceover, linear functions, slopes, and applications. This video is contained in the Canvas module for today. Well, it's there. I don't want to show it out of here.
As we start
Just
to
moving
graph
on.
lines, we might notice that the
And the second video also,
slope of the
calculating slopes, is also there. So you can watch those two videos. I just don't want to show it out of this PowerPoint. It just takes too long. Anyways, a linear equation. A function f is a linear function if it can be written in the form of f of x, which f of x, once again, is the same thing as the letter y, the variable y. Function f of x equal mx plus b, where m, the coefficient, the number that precedes the x variable, is known as the slope, and the b value is the y-intercept. Tells us here if the slope is 1 and the b value, the y-intercept, is 0, you've got what's called an identity function, y equals x. If x is 2, y is 2. If x is 15, y is 15. If your slope is 0, all right, you're not going uphill or downhill, you have a slope of 0, what you've got is a horizontal line. Example, y equals 6, y equals negative 10, y equals 11. Whenever you have just y equals a number and there's no x involved in it, you've got a horizontal line. The slope is 0. All right, it's known as a constant function, a horizontal line. Here's an example here of a line that slants uphill from left to right. The slope would be positive. Here's your identity function, and here's points plotted. X and y are one and the same. Actually, this is the equation right here of this line. Notice your slope is a positive 1/5, so the line slants uphill from left to right. And here is your y-intercept. It goes to the y-axis at 0, 2. The y-intercept is the number 2, positive 2. Here, the y-intercept would be the same as the x-intercept, the origin, 0, 0, 0. Horizontal lines all look the same. They're denoted by y equals negative 2 or f of x equals negative 2. It's the same line. F of x and y mean the same. A horizontal line is indeed a function. A horizontal line would pass the vertical line test. You drop a vertical line through the horizontal line, it'll hit it just in one spot. Vertical lines, unlike y equals something, vertical lines are defined by x equals something. In this case, x equals 4, x equals negative 9, whatever. Notice there's no y term. All right, vertical lines, however, are not functions. They fail the vertical line test because it itself is a vertical line. So it's not very well going to pass the vertical line test. Vertical and horizontal lines. Y equals horizontal, x equals, you got a vertical line. Here he's graphing a horizontal line. The slope, is 0. And the equation is y equals negative 2, 3, negative 2, negative 4, negative 2, 0, negative 2. It is a graph of a vertical line, which is not a function. All right, and the slope is undefined. We're going to find out slope is undefined because when we calculate the slope, the denominator becomes 0. 0, anything divided by 0 is undefined. Vertical lines have slopes that are undefined. Horizontal lines have slope of 0. All right, the formula to calculate the slope. Slope is defined as being rise over run, change in y divided by the change in x. The formula says it's the difference of the y values over the difference of the x values. Now, it could be y2 minus y1 over x2 minus x1. It's the same as taking y1, subtracting y2, and x1 minus x2. Either way you do it, it's going to be the same slope. Difference of the y's over the difference of the x's. Slope. Notice here, all these lines have positive slopes. They all slant uphill from left to right. Notice as the slope gets bigger, this is the yellow one here, slope is 3. This green one, the slope is 2. As the slope gets larger, the line gets more steeper. All right, and this is y equals x right here. So your slope would be 1. So as the slope gets larger, the line gets steeper. And likewise, if you have a negative slope, the line slants downhill from left to right. The bigger the negative number, the steeper the slope. All right. Notice this yellow one here, -3. It's a steeper slope than, let's say, this red line whose slope is a -1. All right. Negative slopes, line slants downhill, left to right, positive slopes uphill. Here again is a horizontal line. Notice when you subtract the y values, all right? Horizontal line, both of these points have the same y value. So in the numerator, when you subtract them, you get 0. 0 divided by anything is 0. Horizontal lines, slopes are 0. You're not going uphill, downhill, slope is 0, nothing. And the reason that the slope of a vertical line is undefined, the denominator on this vertical line, this x value and that x value are similar, right? So you go over 2 and you go up, whatever, and go over 2 and down. The x values are identical. So when you subtract them in the denominator, your difference would be 0. Division by 0 is undefined. Therefore, the slope of this vertical line is undefined. Here's an example of the vertical line x equals -2. No matter what your y value is, y value there is 3, y value there is 0, y value is -4, but x is always -2. Vertical line. It says choose any number for y, x must be -2. If you ever forget this, just kind of do a little table. You plot some points and you realize, oh yeah, it's a vertical line. Vertical line, 2 units to the left of the y-axis. Slope is undefined. Not a graph of a function. Vertical lines on functions. Another horizontal line, y equals 5/2. Choose any number for x. Y is always going to be 5/2. Slope is 0. The grade of a road is a number expressed as a percent. Tells us how steep the road or hill is or mountain. A 4% grade means that the road rises or falls 4 feet for every 100 feet. Federal law states that the vertical rise of 1 foot requires a horizontal run of 12 feet. Find the grade of the curve ramp shown in this figure. All right, so what you've got here is horizontal change over vertical change. Vertical change over horizontal change. Vertical change here, change in y is 3. The change in x is 42. 3 inches divided by 42 inches equals 1/4, and they change that to a percentage. Slopes can also be considered as the average rate of change. We're talking about the SNAP program here, and we've got a graph. And then choosing these 2 points, 2017.2 and 2013, the number of people serviced by the SNAP program, 47.6. So I'm going to use these 2 points and calculate the slope. So there are my coordinates. Slope is change in y over change in x. So change in y, 47.6 minus 17.2 in the numerator. Change in x, 2013 minus 2000. Slope works out to be 2.3. All right. Linear function f given by f of x equal mx plus b is written in a slope-intercept form. The graph of this equation is a straight line, and it's also parallel. If you remember parallel lines, parallel lines are lines that do not intersect. Well, if they don't intersect, they must slant exactly the same way. If they slant exactly the same way, their slopes are identical. Here's just an equation in the format of y equals mx plus b. All right. He says, hey, what's the slope? Well, the slope is the coefficient of the x term. And there it is, -0.25. And the y-intercept is that constant right there, -0.38. So, and sometimes they'll just say, hey, what's the y-intercept? You can just answer -0.38. Here he's giving me the coordinates. Since it's on the y-axis, the x value is 0. 0 minus 3.8. Now, this is an equation that's not in the format of y equals mx plus b. You've got to put it in that format to determine what the slope is. All right, unless it's in that, unless the equation is solved for y, you're not going to know what the slope is. So to solve this for y, what they do is they negate the -6y, and they negate the 3x, and they negate the -7. And they do this by subtracting 3x on both sides and adding 7. And the last step here is to either divide through by a negative 1/6 or, sorry, multiply by a negative 1/6 or simply divide by negative 6. The 6's cancel out here. Negative times negative is positive. Y is equal to 1/2 x minus 7/6. And they got this by taking this negative 1/6 and distributing it times the two terms. Negative 1/6 times a minus 3 is a positive 1/2. Negative 1/6 times a positive 7 is a negative 1/6. So there's my slope. All right, I've got it solved, the equation solved for y. There's my slope, the coefficient of the x term, and there's my y-intercept. Slope is 1/2. Y-intercept is negative 7/6. Given to you, given as a ordered pair, you would say 0, negative 7/6. Now, to graph this, we could use the calculator. By way of doing it, when we know the y-intercept and the slope, we can kind of figure this out. This equation is in the right format. There's my y-intercept right there, 0, 4. All right, so if I plot that, now what we're going to do is, we know the slope is negative 2/3. Here they're putting the negative sign in the numerator. So he says, from my y-intercept, I want a vertical change, all right, of negative 2. So from negative 0, negative 4, I want to come down to, then I want a horizontal change of positive 3. What that does is determines a second point for me, and I can connect these 2 points and form this red line. I could have put the minus sign in the denominator. Positive 2 divided by negative 3 is also negative 2/3. Then I would have gone a vertical change of positive 2 and a horizontal change of negative 3 would have given me this point. But notice, all of these 3 points are on that exact same line. So when you have a negative, if you're doing it this way, you can put that negative sign in the numerator or the denominator. It wouldn't make a difference. But here again, you got a calculator that's going to graph this for you. So plotting points and doing it this way, I mean, it's multiple ways of getting to the same conclusion. All right, I hope that helps.